I'm going to show you how to find an exponential regression for a set of data. First thing though, I need to generate some data. So I'm going to take these 5 coins and flip them until turning up tails eliminates them. I have not flipped them any times yet, so 0 flips means I still have 5 coins. Just give them a quick flip, and it looks like I've eliminated one of them. After 1 flip, I'm down to 4. So this one is gone. These 4 remain. Let's flip them again. And it looks like I've got another tails. So after 2 flips, that's 3 coins left because that one is gone. Okay, 3 pennies. Still all heads. So after 3 flips, I still have 3 coins. Hopefully this doesn't go too much longer, but let's see what we've got. All right, there is 1 elimination there. After 4 flips, we're down to 2 coins left. How long will they last? All right, and then they're gone. So the 5th flip results in 0 coins left. Try saying that 3 times fast. 5th flip. All right, so we're going to have to go into the calculator's data menu. And this gives you a place where you can enter a table of values just like this. So entering these numbers 0, 1, 2, 3, 4, 5, and then on the second column 5, 4, 3, 3, 2, 0. That is the complete table. Now I do have an issue here which I'll show you in a second, but ordinarily what you would do is press second data. That gets you to the statistics and regressions menu, which is StatReg, and you would scroll down, choose whatever regression or statistics you want. We want an exponential regression. Now if I press enter, it's going to ask me for some options. Yes, those are the lists I just filled out. Everything else is standard, but this is going to turn up an error, and the reason why is because of that 0. You see, exponential functions can approach 0, or they can start kind of from 0, so to speak, but they can never actually be 0. So this number cannot be part of a set for an exponential regression, so we're going to have to straighten that out. If I go down to the bottom of this, I can just delete the entry in the last row and then perform the regression again. Everything the same. It's going to give me a bunch of values. Okay, so I'm just going to round this for the sake of making this writable. If A is approximately 4.959 and B is approximately 0.809, then this is in the form A times B to the X, meaning that the regression that this calculator has generated for this data is 4.959 times 0.809 to the X. This is the base, and that is a constant that's being multiplied out in front of it. Now, if you put that data into Desmos to visualize it, you can compare it to the function that the calculator gave you. It said 4.959 times 0.809 to the X. And as you can see, that curve follows that set of points pretty nicely. That's a really good regression. Now, if I didn't have the benefit of the calculator and I just had Desmos to attempt to find a curve, that's not impossible. You just have to choose a form. Just for the sake of comparison, I'm going to choose something else. I'm going to go with A times E to the bx. Rather than modifying the base, I'm going to modify the exponent with some multiplication. So if I just put some sliders on here, I can tell, first of all, the graph is going in the wrong direction. I'm looking at a graph of growth. I should be having a graph of decay, so I'm going to need to make this negative. Now it's facing the correct direction, and if it's too big, then, well, too far negative, then it's very sharp. A negative fraction is what I'm looking for, and that might be about somewhere in here. I'm not sure where. Anyway, the value of A is going to shift this over into approximately the correct position. So if I just play with this a little bit, I think I should be able to work something out. That's not bad. I don't think that's too bad. Let me compare that to the one the calculator gave. Yeah, they're pretty close to each other. I'm sure if I went far enough away, they'd diverge. But if you're looking for an equation, some sort of exponential function that models data, you can use the calculator to get a very precise analytic solution, or you can just kind of eyeball it and use your intuition to guide you.